Lungang, Lungang, let's go. Welcome back to Nick Does Maths. We got floating head Nick today. A little bit different. We can do this. I'm going to go through a question about a quartic that was popped over on the Lungang subreddit. Go check it out. If you have further math style questions you want me to go through, you can always pop them over there. So we are looking for the roots of this quartic y equals x to the 4 minus 4x cubed plus 10x squared minus 12x plus 1. Now, one thing we might try and do with a quartic is try and start factorizing it and start using the factor theorem. Look for a few different factors. But if we have a little go, x is 1 isn't going to work. That's easy. X is 2 doesn't work. I'm not going to go through huge details, all of these. But basically, there are no easy factors. So we're going to have to try something else. So one thing I'm going to try is maybe we look at the derivative. Maybe the derivative will tell me something. Well, that's 4x cubed minus 12x squared plus 20x minus 12. Well, that factorizes. This one does, which is quite nice. Minus 3x squared plus 5x minus 3. And actually looking at that, that does factorize as well. And x is 1 is a solution, is a root of this, so x minus 1 is a factor. X squared minus x squared minus 2x plus 3. Now this x minus 1 has me thinking. And in fact, if we look at this quadratic, now this quadratic does not factorize. You can check its discriminant, it will be negative. However, we could complete the square. If I complete the square on this bad boy, what we see is it's in terms of x minus 1. So this suggests to me that I am going to make the substitution z is equal to x minus 1 and see what happens. So z plus 1 is equal to x, and let's plug that in. So I end up with z plus 1 to the 4 minus 4z plus 1 cubed plus 10 z plus 1 squared minus 12z plus 1 plus 1. Now, why am I making this substitution? Z equals x minus 1. Well, when you look at this, right, this tells me, right, this is symmetrical. About x equals 1, and this will be anti-symmetrical at the same place, right? But both of these has symmetry around x equals 1. So let's shift our entire graph by 1 and see what happens. Okay, z plus 1 to the 4. I'm going to write this way. Z to the 4 plus 4z cubed plus 6z squared plus 4z plus 1. Then minus 4 times, we'll do the cubic, z cubed plus 3z squared plus 3z plus 1. Then we'll do the quadratic, plus 10 times z squared plus 2z plus 1. And then the linear one, minus 12 times z plus 1. All of that equals 0. So what do we end up with? Z to the 4. Okay. 4z cubed minus 4z cubed, nothing. That's kind of neat. Z squared minus 12z squared is minus 6z squared, plus 10z squared is plus 4z squared. Z's 4z minus 12z is minus 8z, plus 20z is 12z, minus 12z, no z's. 1 minus 4 is minus 3, plus 10 is... 1 minus 4 is minus 3, plus 10 is 7, minus 12 is minus 5, equals 0. Oh, no, we forgot that cheeky plus 1. We forgot that cheeky term there, so this is a minus 4. Too bad, that was going to factorize for me. Got excited there for a second. But what we now have is we've now got a quartic, but without the z cubed and the z, so it's effectively a quadratic. I could complete the square on this, z squared plus 2. Gives me minus 6, 0. Ooh, Nope, minus 8. There we go, we can do this. So z tells me that z squared I got the z squareds right. Yep, is minus 2 plus or minus root 8, which is 2 root 2. Now z squared needs to be positive, so the only option here that works is the minus 2 plus 2 root 2. So that tells me that z is plus or minus square root of 2 root 2 minus 2, which tells me then that x is 1 plus or minus square root of 2 root 2 minus 2. Not bad. Not bad at all. Hope you enjoyed that one. A little bit interesting is how we get going, but that transformation of variable turns a horrible Quartic into one that is doable. If you enjoyed this, don't forget to like, subscribe. How do you find the floating head style video for this one? A little bit different. Thought we'd try something out. Let us know in the comments below. In the meantime, I will see you soon. I was Nick. This was Maths. Bye bye.